Alrighty, this is about how do you do the bonus pull at an angle. Here we go. So Newton's law with friction, big N. All right, so I have to find the acceleration of this system. So first you want to do your free body diagram. Now I'm going to do it kind of quick, and it might be a teeny bit off, but I'll be okay. So it's 0.9 kilograms times 9.8 or 10. So that's about a 9 Newton force downward. Whoops, I forgot to turn on my annotations. And let's go pink. All right, so we got a 9 Newtons downwards, and that's the force of gravity. All righty. Now there's a pulling force of 5.9 Newtons. The problem is, there's my angle. It's not a problem at all, 39.5. So the next thing I want to do is separate this into X and Y components. So this is going to be my X component this way, and this is going to be my Y component this way. Keep in mind that's 39.9 degrees, this angle right over here. So if I want to find the F of, let's move to the F of Y since I have that one already. So that's the opposite in the hypotenuse I'm going to use. That's the sine. So if I do the sine, which is the SO, of 39.9, that equals the opposite side over here. I'm going to call that my Y value divided by my hypotenuse, my 5.9. Okay, so my Y value, the reason I have to do that is I really don't know, I have friction here, and I don't know how big the friction force is yet. So I need to know what the friction force is backwards. Get to that in just a moment. But when I have it at an angle here, you usually got to separate things or resolve this into your X and Y components. All righty, so I've got a 39.9 sine times 5.9, 3.78. Well, that's reasonable, 3.78 newtons. And then if I do my X over there, let me go to the red here. So I have to find my X component of that. Well, that's the cosine, the adjacent, and the hypotenuse. So the cosine of 39.9 equals my X divided by my hypotenuse, the 5.9. So I have 39.9 cosine times 5.9, 4.53. Guys, I have 3 sig figs there. Because of that, I'm going to go back and change my pink number, if you don't mind. I'm going to actually do the 0.9 times 9.81. I want to see if I can get things spot on. So instead of 9 newtons, this is really a force of 8.83 newtons. All righty. So here's the story. Of this component, I don't know if it's speeding up or slowing down because I don't know what the friction force backwards on this thing is yet. I really don't know what the friction force is. I have a coefficient, but to find the friction force, and now I know the Y. Let me go back and do something I know how to do. I can do the normal force. Well, you might think, hey, isn't the normal force the weight, 8.83? Not in this case, because we have a force pulling up by 3.78 newtons. So that means the normal force, Fn, plus the Y is the same as the 8.83. Does that make sense? Because all the vertical things are going to sum up. We're not going up or down with this thing. Okay, we're not going up or down. So we know the up and down forces have to be balanced. So I know that the 8.83 newtons, one way, has to equal the normal force plus the Y going in the other direction. So that means if I want to solve for the normal force there, that's going to be the 8.83. My face is going to get in the way, it looks like over there, minus the Y, which is a 3.78. Okay, so 8.83 minus 3.78 is a grand total of the normal force works out to be, the F of N, whoops, it's over here, 5.05 newtons. Well, the reason I have to do that is I don't know what my friction force is, so I can't find my acceleration without knowing my friction force. So the coefficient of, I'm assuming it's moving here, kinetic friction is the kinetic friction force over the normal force there. And so if I'm solving for that kinetic friction force over here, that is the coefficient times the normal force. Coefficient is indeed 0.31 to 2 sig figs. And the normal force is actually 5.05. Alrighty, so times the 0.31, that means the friction force is a measly 1.57 newtons. Okay, so my up and down stuff cancels out, so I'm not going to worry about that stuff anymore. So to find what the acceleration is, I only have to sum up these forces. Because sideways, I have a friction force of 1.57 newtons, okay? That's what I found here. But here, I've got a 4.53. So this is 8.83 down. That plus that is 8.83 going up. So that cancels out. I just need to know my difference in forces here. So if I want to sum up all my forces, which is mass times the acceleration. There's the mass of the thing was 0.9. So I'll get to that. So let me get that in a moment. So the sum of all forces is the 4.53 forwards minus the 1.57 newtons backwards. So 2.96. So I have a net force of 2.96 newtons. Well, that equals the mass times the acceleration. So I'm running out of room. I'm going to go clear up this corner over here. So the mass times acceleration is 2.96. The net force, or sum of all forces, is still the 2.96 newtons. The mass is only 0.9. I know it's 1 sig fig, but they're going to go to a couple sig figs in their answer there. This is in kilograms. Remember, a newton is a kilogram meter per second squared, so the kilograms cancel out, will be in meters per second squared. So divided by 0.9, and my final answer is 3.29 or 3.3 meters per second squared. Bam! My 2 points, give them. Here it comes, guys. My 2 bonus points. Oh, I got to undo this thing. Ending. So name Ted. Oh, Ter. I guess my name is Ter. Okay. And my acceleration is 3.3. Want my points now. Submit. Acceleration of the system was 3.29. Yeah, you only had 2 sig figs, pal. You're kind of overdoing it. So the answer is, in fact, 3.3. My answers are not good. They're great. All right, guys, that's how you do this one. Let me stop the share. And done.